Okay, we're going to go over the 2003 Part B section, since we didn't have time in class. Let's try and do this efficiently as possible. A particle moves along the x-axis so that at any time t, its velocity is given by that. What is the acceleration of the particle at time equal 4? Are you joking me? So all you do is you take the derivative, cosine of 0.9p, because the derivative is acceleration, so that would be 0, plus throw the constant on the side. The derivative of cosine box is negative sine box times the derivative of box, which is 0.9. And then you simply plug in 4 for t, and then punch that in on your calculator and pick out the answer. 77. So here's negative 3, and there's 3. We have a graph that looks like this. Ooh, and this is the graph of f. If the area of each region is 2, so 2, 2, 2, what is the value of the integral from negative 3 to 3 of f of x plus 1 dx? Well, using your properties of integrals, first you split it up, plus the integral from negative 3 to 3 of 1 dx. And of course, what is this part equal to? Well, one is, you can think of the graph y equal 1 as a horizontal line, right? 1 unit above the x-axis. And think of it from negative 3 to 3, the area would be 6, right? Or you can go, the antiderivative of 1 is x. From negative 3 to 3, plug in the top number, plug in the bottom number, subtract, and you still get 6. And if this is the graph of f, the integral from negative 3 to 3 tells you the area. But since these two are below the x-axis, they're going to count negative. So negative 2 plus positive 2 plus negative 2 is negative 2. So negative 2 plus 6 is 4. Number 78. The radius of a circle, this looks like a related rates problem, is increasing at a constant rate of 0.2 meters per second. So dr dt, or r dot, is equal to 0.2. What is the rate of increase in the area of the circle? In other words, dA dt, at the instant when their circumference is equal to 20 pi. So we need to write an equation. Since we're trying to find dA dt, we need to write an equation that relates the area with the radius somehow. So area equals pi r squared. Take the derivative with respect to time. dA dt equals 2 pi r dr dt. So in order to compute dA dt, you need to know dr dt and r. But we already know dr dt is 0.2. What am I going to plug in for r? Well, it says at the moment when the circumference of the circle is 20 pi. Well, the formula for circumference is 2 pi r, and if that's equal to 20 pi, cancel the pi's, divide by 2, r equals 10, and that's what you plug in for r. Punch that in on your calculator and pick out the answer. Or maybe you don't even need to do that. No. I don't think you even need a calculator for that one. That's a sign of weakness. Okay, for which of the following does the limit exist? Again, in order for a limit to exist, the graph has to approach the same point from the left and the right. So in graph number 1, yes, it's approaching the same point from the left and the right. In number 2, yes. In number 3, no. So the answer is 1 and 2, whatever that you pick out the letter. That's an insult to my loins, this problem. The function f is continuous and differentiable from negative 2 to 1. That means smooth and continuous. So this kind of problem, you should draw a picture. F of negative 2 equals negative 5, which means that's the point, negative 2, negative 5. And f of 1 is equal to 4. So here's the point 1, 4 there. So if it's going to be smooth and continuous, right, it could be a straight line or it could be a curve, something like that. Okay, which of the following statements could be false? There exists a value of c somewhere between negative 2 and 1 such that f of c equals 0. In other words, somewhere in between here and here, the y-coordinate will be 0, somewhere. Yes, this is the intermediate value theorem. If the y-coordinate is negative 5 here, and it's 4 up there, somewhere in between it has to hit 0, right? Because it's smooth and continuous. That There exists a value of c such that f prime of c equals 0. That means somewhere in between here and here, the slope of the graph has to be 0. I don't think so, because if you look at the graph we drew, or if you just drew a straight line, the slope will not be 0, so the answer is B already. But let's just go through the others just so you understand everything. Is there a value of c such that f of c equals 3? Yes, again, because 3 is between -5 and 4. To get from -5 to 4, you have to pass somewhere where the y-coordinate is going to be 3. Again, that is the intermediate value theorem. There exists a value of c such that f prime of c equals 3. Yes, because of the mean value theorem, because the coordinates of this point are -2, -5, and this is the point 1, 4. So the mean value theorem says, if you have a smooth and differentiable function, which is differentiable, then there's at least one value of c such that f prime of c is equal to f of b minus f of a all over b minus a, which comes out to 9 over 3, which is 3. So D is the mean value theorem, which applies all the time in this case. And there exists a value of c between -2 and such that f of c is greater than f of x for all x on the closed interval. In other words, there is a point that is greater than or equal to all the other points. So no matter what graph you draw, is there going to be a point greater than or equal to all the other points on the graph between -2 and 1? Yeah, like in the picture I drew here, right there. That point there is greater than or equal to all the other points. And it doesn't matter what graph you drew. What if you drew it like this? Then right there, that point up there is greater than or equal to all other points in the interval. So basically they're saying somewhere there's going to be a maximum. Yes. Okay, a lot of you don't like these theoretical problems. Draw a picture right there. Takes care of it. 81. F is the function defined by f prime is equal to sine of x squared plus 1. How many relative extrema, that means maxes and mins, does f have between 2 and 4? Now, how do we find maxes and mins? You find the first derivative and you make a number line for it, right? So here's the first derivative. It's given already. So what you need to do is graph this on your calculator. Okay, now do I need to do this? Apparently. So make sure your calculator is in radian mode, which it is. Okay, so y equals sine of x squared plus 1. Woo! And then you should set your window x min 2, x max 4, because they're only talking about between 2 and 4. I get a graph that looks like this. So when if you were to make a number line for it, it touches the x-axis 4 times. 1, 2, 3, 4. It's below, above, below, above, below. So f is decreasing, f is increasing, f is decreasing, f is increasing, f is decreasing. What's the question? I forget. How many extrema does it have? Well, there's a minimum there, a maximum there, a minimum there, a maximum there, so that's 4. Do what you know how to do. Take the derivative, make a number line. But yeah, they actually told you the derivative. Okay, 82. The rate of change of the altitude. Now, rate of change means derivative. Okay? The derivative of the altitude of a hot balloon is given by this. Where t is between 0 and 8. Which of the following expressions gives the change in altitude? So, this is the derivative of altitude. So what will give the change in altitude? In other words, you see, this is where you're going to make the connection. The integral from 0 to 8, no, moose breath, gives the change in altitude of the balloon during the time that the altitude is decreasing. Aha! So it's not 0 to 8. How do you determine when a function, in this case altitude, is decreasing? When its derivative is negative. But this is the derivative of altitude. We need to know when this is negative, so we go to our calculator and we graph this. So we got x cubed minus 4x squared plus 6, and I'm going to do a zoom standard to start out with. Woo! This is what I get. So when is it negative between here and here, right? Because we're only talking about from 0 to 8 anyway, right? So we need to compute these numbers there, and you can kind of see that, what is it, 1 point something to 3 point something. So the answer has to be either A or D. But which one is it? Are you integrating the derivative of altitude, or are you going to integrate the derivative of the altitude? Now they want the change in altitude. So what is this point? This was 1 point something. I guess it's 1.572, and this one there is 3.514. So 1.572, 3.514. Now if you want the change in altitude, this is code red basically. You have to integrate the derivative of altitude, which is this. Right? Because if this is the derivative of altitude, when you find the antiderivative, you're going to get the altitude. What do we call altitude at 3.514 minus the altitude at 1.572. Right? And doesn't that give you the change in altitude? Yup. Okay, 83. The velocity of a particle moving on the x-axis is given by this velocity, e to the t plus t e to the t. What is the average velocity? Okay, so when you see the word average velocity, that means the average value of the velocity from 0 to 3. I know how to do average value. 1 over b minus a, integral from a to b of the velocity, so this thing, dt, math 9 that and you got your answer. I think you guys can math 9. 84. A pizza heated to a temperature of 350 degrees is taken out of an oven and placed in a 75-degree room at time equals 0. The temperature of the pizza is changing at this rate. Now this is a rate. In other words, this is the derivative. Derivative means rate. Rate of change. Instantaneous rate. All mean the same thing. Derivative. So the temperature of the pizza is changing at this rate. This is the derivative of the temperature right here. So if you want to call it T prime. Okay? To the nearest degree, what is the temperature of the pizza at time equal 5? Aha, so one way you can do it, well, if you know the derivative of temperature, to find the temperature, you do the antiderivative of this, which you can do, right? You should be able to find the here, I'll show you 2 ways. Which is, show the 110 on the side. What's the antiderivative of e to the box? Is it just e to the box? No, you gotta adjust for the derivative of box, so you gotta divide by negative 0.4, and then don't forget to put the plus c. But they give you information there to figure out what c is. And then if you want to find the temperature at t equal 5, just plug in 5 for t there. But then you got to tack on the plus c there. A better way, since you're using a calculator, is to do code red. You integrate the derivative of the temperature from 0 to 5. And that's going to give you the temperature, the antiderivative of the derivative of temperature is the temperature at 5 minus the temperature at 0. This is what we're trying to find, which means we need to know this and this. This you can math 9 on your calculator. And do we know what the temperature of the pizza is at 0? Is it 350 or 75? Ooh, they're giving you extra information there. What is the temperature of the pizza when you take it out of the oven? It's 350, so this is 350. So the answer is going to be math 9 this on your calculator and add 350. Code red, baby. Hopefully by now you guys are getting the code red, when to use it. Okay, 85. If you use a trapezoidal sum and it over approximates the integral from 0 to 4, and a right Riemann sum under approximates the integral from 0 to 4, which of the following could be the graph of f? Okay, now what are we looking for then? What determines in a trapezoidal sum if it's going to overestimate or underestimate the concavity of the graph. So if we want trapezoids to overestimate the graph, then we need the graph to be concave up, right? Here, let me exaggerate it so you can see. If the graph is concave up, see that when you make trapezoids, the area of the trapezoid is bigger than the actual area. So we're looking for something that's concave up. So the answer is either A or D now. Now, if a right Riemann sum under approximates it, then what? Is the function going to be increasing or decreasing? Well, if the function is decreasing and you make rectangles and you use the right endpoint to cap off the rectangle like this, then the areas of the rectangles are less than the actual area, right? So we need the graph to be decreasing and it has to be concave up. And so which one is it? The answer is A. 86. The base of the solid is the region in the first quadrant bounded by the y-axis, the graph of y equal tan inverse x, the horizontal line y equal 3, wait, so pi over 2, oh, so y equal 3, you can graph this on your calculator, and the vertical line x equal 1, which is there. So this is the region right there. Okay, this is y equal 3, x equal 1, y equal tan inverse x. No excuse because you can graph this on your calculator, right? For this solid, each section perpendicular to the x-axis is a square. So put this on a cutting board. I slice it. I remove a slice. It's going to be a square. The length of this rectangle is the base of the square. So the length of the rectangle is simply top minus bottom, which is 3 minus tan inverse x, which will be the length of the side of the square. So if you know the side of the square, how do you find the area? You square it. But it has a thickness to it, which is dx. And then you add up all of these slices from 0 to 1. Math 9 that on your calculator and you got the answer. 87. The first derivative of a function is given by this 1 plus x plus x cubed. That's kind of ugly. What is the x-coordinate of the inflection point? Now, to find points of inflection, you need to compute the second derivative and then graph it, and you want to see where it changes signs, right? Because whenever the second derivative changes sign, that's when you're going to have a point of inflection because it changes concavity there. So there's two ways you can do this since you have a calculator. One way is to take the derivative of this, then you got to use the quotient rule, and that's pretty ugly to punch into your calculator. Yeah? Watch this. Low d high minus high d low 1 plus 3x squared all over denominator squared we go. So you can punch that in on your calculator and graph it and see where it crosses the x-axis. What are they asking for? What is the x-coordinate? Yeah, so we want to see where it crosses it. But how long is it going to take you to punch that in on your calculator? Now remember, your calculator can graph derivatives now. So if you punch this in as y1 on your calculator, then how do you tell your calculator to graph the derivative of that? I taught you this, but you probably forgot. Math 8, n deriv, y1, graph the derivative of y1 with respect to x at x. Graph that on your calculator. This will give you the derivative of that, and then you see where it crosses the x-axis, and that's your answer. Either way, they'll both come out. It's like eating oatmeal. 88. On the closed interval from 2 to 4, which of the following could be the graph of a function f with the property that 1 over 4 minus 2, this looks like an average value, yeah? The average value of the function is 1. Now, this is 1/2, right? If you multiply both sides by 2, then you get this. So, which of the following functions is, remember, when you find an integral of a function, that tells you the area between the graph and the x-axis. So, which of the following functions is the area between 2 and 4 going to be 2? Now, by looking at these, it has to be C because, look, 1, 2, 3, 4. the graph looks like this. If you compute the area between the graph and the x-axis, isn't 1/2 base times height, so that's going to be 1, and that's 1, that's 2. Because the other ones are not 2. So that one's it. The integral tells you the area between the graph and the x-axis. Number 89. Hey, we're zooming through this. Yeah, baby. 89. F is a differentiable function. F of 2 is equal to 3, which of course means, let's just write it down. F prime of 2 equals -5. And G is a function defined by this. Which of the following is the equation of the tangent line to the graph of G when x is 2? Now remember, this is G right here. To write an equation of a tangent line, you need a point and you need the slope. Now we know the x coordinate is 2. How do we figure out the y coordinate? Well, plug it in here. G of 2 is equal to 2 times f of 2. But it says here f of 2 is 3, so 2 times 3, this is 3, is equal to 6. So we know the y coordinate has to be 6. So we know that the answer has to be C, D, or E already, right? If you use point slope form. Now what we got to do is figure out the slope. Well, to compute the slope, we need the derivative. So how do you compute the derivative of G? Well, since I see a product, I'm going to have to use the product rule. Derivative of the first, leave the second one alone, plus leave the first one alone, derivative of the second. So to compute the slope though, at this point, it is not the slope until you actually plug in that number. So if you plug in 2, you get f of 2 plus 2 f prime of 2. Now f of 2 is given up here as 3, plus 2 times f prime of 2 is equal to -5. So 3 plus -10 is -7. That is the slope. So therefore the answer has to be D. Wow, only 3 more problems. Am I pretty? Number 90. For all x in the closed interval from 2 to 5, the function f has a positive first derivative, which means the function is increasing. The y coordinate's got to be getting bigger. And a negative second derivative, which means the graph of f has to be concave down. So we're looking for something that's increasing and concave down, so something like that. Which of the following could be a table of values for f? Come on! How about just plot it and look for something that looks like that? Right? So again, you need to know the meaning of the first derivative and the second derivative. 91. Our particle moves on the x-axis so that its acceleration is this. If the velocity of the particle is 2 at t equal 1, then the velocity of the particle at time equal 2 is what? So if you know acceleration, to find velocity, you have to do the antiderivative. But in this problem, we can't find the antiderivative of that. That is when you do code red. So you integrate the acceleration from 1 to 2. Because see, look, at 1 we know, and 2 is the one we want to find. So, using the fundamental theorem of calculus part 2, what is this equal to? You find the antiderivative of this, which is velocity. Plug in the top number, plug in the bottom number, subtract. We are trying to find the velocity at 2. This is what we're trying to find, which means I need to know these two things. But we know that v of 1 is 2, and this you can math 9 on your calculator. So the answer is this number plus 2. Code red, baby. And then 92. G is the function. I smell the fundamental theorem of calculus part 1, but let's just see. This is the function g. When is g decreasing? How do you determine if a function is decreasing when its derivative is negative? So we need to compute the derivative of this, and you do that by using the fundamental theorem of calculus part 1. How do you take the derivative of an integral from constant to something? You take the something and plug it in, which is sine of x squared, and then you multiply it by the derivative of x, which is 1. Some of you are still shaky on this fundamental theorem of calculus part 1, but that's it right there. So I need to know when that is negative between -1 and 3. So you graph this on your calculator, y1 equals sine of x squared. Why am I even writing it? Just do it. So take out your calculator, y equals sine of x squared. And I'm going to make the window from negative 1 to 3. Negative x min, negative 3. No, negative 1, fool! Negative 1 to 3. And now I graph it. Okay, my y min and y max are two junk, so I'm going to change that. Negative 2 to 2. Woo! Okay, there you go. So from negative 1 to 3, this is what I'm seeing. So that's negative 1 to 3. Now what's the question? On which of the following intervals is g decreasing? So we want to know, when is the derivative negative? This is the derivative. When is it negative? Between these 2 points right there. Okay, so do we actually have to calculate it, or can we pick it out? Because that looks like 1.7 something, and the other one looks like 2.5 something. I think the answer is D. And we don't actually have to calculate it exactly, because we can just look at the answers that are given. And there you go.
Some of you need to kick it up a notch, real fast. George is not happy.